Hello everyone, I am Sunita Swain, Faculty of Data Science at Techno India University, Kolkata. Today, I am going to explain the concept of clustering in terms of artificial intelligence, or you may say in machine learning. What is actually clustering is? So this is a particular term used in machine learning or artificial intelligence. Obviously, machine learning is the subset of artificial intelligence. Now, what is this clustering is? So, clustering is sometimes our data is not labeled and we want to know how similar the data items in our sample are to each other. As an instance, we might be interested in determining whether a counterparty is a safe or an unsafe counterparty. Furthermore, sometimes we are interested to know how similar a data item in our sample is to all of the other data items. So, different clustering algorithms are there. These algorithms can help us distinguish bad data items from good data items. So basically, clustering means grouping of data elements. Similar kinds of elements are grouped together. So differ sometimes depending on different categories of products, different types of clusters are formed. Then we are coming to the term, what is hard clustering? Hard clustering is about grouping the data items such that each item is only assigned to one cluster. As an instance, we want the algorithm to read all of the tweets and determine if a tweet is a positive or a negative tweet. So different types of categories. Some of the categories we are having one special characteristics, or it can fall under one particular section or particular cluster. So what are the hard clustering algorithms? The best type of hard clustering algorithm is K-means. K-means is a famous hard clustering algorithm whereby the data items are clustered into K clusters such that each item only belongs to one cluster only. It will not fall under several groups. It is under one section or one cluster only. So I have a read on in my article that explains unsupervised learning and K-means clustering in depth. So unsupervised machine learning, clustering and K-means. Next come to the concept of soft clustering. Sometimes we don't need a binary answer, either in cluster 1 or cluster 2. Either it is 0 or 1 or true or false. Soft clustering is about grouping the data items such that an item can exist in multiple clusters. Some of the instances occurs in daily life. On particular object or a particular category or data item It falls under multiple types, multiple groups, more than one category. What are the soft clustering algorithms? So fuzzy C means is a famous soft clustering algorithm. It is based on the fuzzy logic and is often referred to as the fuzzy C-means or FCM algorithm. The way fuzzy C-means algorithm works is that the items are assigned probabilities which are essentially expressing the strength of the belonging of the item into the cluster. A membership vector is created during this fuzzy C-means process, which express the probability of the membership, ranging from 0 to 1, which indicates how similar an item is to the mean of the cluster. So in the vector given in this study material, we can see that a data item belongs to two clusters named M2 and M3. So this membership vector is created for each of the data item. So the sum of the memberships is equal to 1 for an item. The concept is very similar to the way k-means work. Each item is randomly assigned to the clusters and the steps are repeated until none of the memberships are updated for an iteration. So in hard clustering algorithms, the membership vector is binary in nature because either an item belongs to a cluster or it doesn't. So for a soft clustering algorithms, we need to compute a fuzziness coefficient that controls the degree of fuzziness. So in soft clustering algorithm, we need to compute how the fuzziness coefficient controls the degree of fuzziness. Let me explain one popular kind of clustering algorithm that is hierarchical clustering. Sharing the screen. Let me explain the most popular kind of clustering algorithm that is called as hierarchical clustering. So hierarchical clustering is used for data mining. So hierarchical clustering method works via grouping data into a tree of clusters. Hierarchical clustering begins by treating every data points as a separate cluster. Then it repeatedly executes the subsequent steps It identify the two clusters which can be closest together and merge the two maximum comparable clusters. So, in this particular clustering algorithm, we need to continue these steps until all the clusters are merged together. So, in hierarchical clustering, the aim is to produce a hierarchical series of nested clusters. A diagram called dendrogram. Dendrogram means it is a tree-like diagram that statistics the sequences of merges or splits. Graphically, it represents this hierarchy and is an inverted tree which describes the order in which the factors are merged, that is bottom-up view, or cluster, or breakup, that is top-down view. So basically, hierarchical means it is based on the properties of tree architecture. So different levels are there, so the hierarchies are maintained. So the basic method to generate hierarchical clusterings are agglomerative and divisive. So one by one, I'm going to discuss. So what is this agglomerative procedure for clustering? So agglomerative initially consider every data point as an individual cluster. Each of the data point it considers as the individual cluster. And at every step, merge the nearest pairs of the cluster. It is a bottom-up method. At first, every data set is considered as individual entity or cluster. At every iteration, the clusters merge with different clusters until one cluster is formed. So, algorithm of agglomerative hierarchical clustering is, so what are the different steps are followed for this hierarchical clustering? That is the first step, calculate the similarity of one cluster with all the other clusters. Means calculate the proximity matrix. Consider every data point as an individual cluster. There is a second step. Means every data point should have considered as the individual cluster. Merge the clusters which are highly similar or close to each other. Then recalculate the proximity matrix for each cluster. Then repeat step 3 and 4 until only a single cluster remains. So this is the algorithm or step-by-step procedure of agglomerative hierarchical clustering. So let us see one example. What is the graphical representation of this algorithm? using dendrograms. So this is just a demonstration of how the actual algorithm works. No calculation has been performed. All the proximity among the clusters are assumed. Let's say we have 6 data points, A, B, C, D, and E, F. Let us consider these 5 data points. Each individual is considered as a cluster. So look at the diagram. So this is an agglomerative approach. Here, how these algorithms have been stated accordingly, how this particular steps in the diagrammatic manner, how it shows. See, we are having 6 data points: A, B, C, D, E, and F. Step 1, the similarity of the data points are grouped together. So among these 6, which are similar elements, we had made the groups. So B and C, the similarities found. D and E, some similarities found. By combining this, another cluster is formed, that is BC. And by taking into consideration the similarities between D and E, DE cluster is formed. Means B and C has been combined to make another cluster. Because we had this procedure that is in agglomerative hierarchical clustering. The similarity between the data elements of which is considered as the cluster, each data point, how the grouping of the data points are there to make the clusters. D and E, some similarities are there. That's why the DE cluster has been formed in the step 2. So step 2, we are getting 2 different clusters by combining another 2 to each. Then come to the third step of the algorithm. Third step, according to the similarities, along with DE, another data point has been combined, that is F. So in step 3, we are getting another cluster, that is DEF. So according to the similarities, how one particular group is to be made. So DEF is one cluster now in the third step, combining 3 clusters together, 3 data points together. Let us come to the fourth step. So each and every step, what are the combination or similarities we are getting? Accordingly, we are forming the cluster. In step 4, that is a combination of step 2 and 3. It is combined as B, C, D, E, F. Now, we are moving to step 5. So, step 5, only the data point A has been left till end. So, the cluster of the data points in till 4th is B, C, D, E, F, means 5 data points have been already clustered. Only A is left. And finally, in step 5, by combining A, the final cluster has been found, which is A, B, C, D, E, F. So, this figure shows agglomerative hierarchical clustering. Here in this explanation, this algorithm steps along with the example which I explained now, it has been stated. So, merging of the data elements. So in the single cluster, how to calculate the distance of one cluster or similarities from all other clusters accordingly, the steps are followed. Several steps are considered accordingly to form different clusters. So at the end, or the fifth step of the algorithm, at last the two remaining clusters are merged together to form one single cluster. So the actual purpose of hierarchical clustering is to make number of clusters like on tree architecture, whether it is from left to right approach or top to bottom approach, the hierarchies are maintained in two ways: agglomerative or divisive. Agglomerative, the steps here, repetition of this procedure by comparing it and merging together. Number of clusters are grouped together, or number of data points are grouped together to get another point or another cluster. Let us come to the divisive procedure. This is also one kind of hierarchical clustering. So we can say that divisive hierarchical clustering is precisely the opposite of the agglomerative hierarchical clustering. So in divisive hierarchical clustering, we take into account all the data points as a single cluster. And in every iteration, we separate the data points from the clusters which are not comparable. So at the end, we'll have n number of clusters. This is just the reverse approach of agglomerative. Just it is the opposite concept of agglomerative hierarchical clustering. So let us consider this algorithm along with the diagram. So in this diagram, this is from left to right approach. The diagrammatic representation has been given. Step 1 is having the entire cluster as one. Entire data elements are in one cluster. That is A, B, C, D, E, and F. Then it has been divided into two sets in step 2. Means in the step 2, we are getting another cluster. Means a single element has been bifurcated from A, B, C, D, E, F. So A has been bifurcated. Then another cluster left in step 2, that is B, C, D, E, F. So just the opposite. In agglomerative, we were combining. In divisive, we are dividing. It is a major concept, main concept. So in step 2, again, according to the different types of grouping of elements, we are dividing into another clusters, that is D, E, F and B, C. D, E, F in step 3 will be again divided into two sets. One is single element F and another two elements left from DEF, that is DE. And in step 4, see this step numbering, you see step 1 will have the entire cluster, enter all the data points. In step 2, we'll have the bifurcation of one single element and along with some other clusters left. In step 2, divisions are made. In step 3, it is having 3 elements. And in step 4, we are having 4 elements with 2 each. But our goal is to separate each individual data points. Each individual data point is considered as the cluster. So, in step 4, this B, C, and D are formed. And in the last step, step 5, all individual clusters formed by step 4 has been divided into single units or single cluster. So now, as the output, we are getting the cluster as single data elements. All individual data elements are formed as separate clusters in step 5. So the actual purpose of this divisive hierarchical clustering is to divide the entire cluster or the complete group, the available data points, into all individual data items. Just the opposite of agglomerative, where the agglomerative approach will divide the data elements, grouping the data elements, which makes one cluster from all individual ends. So by these diagrams, 2 diagrams, so that is what is the direction of arrow? Either it is from bottom to top or top to bottom. Which approach we are considering over here? So this diagrammatic representation with the same data points like A, B, C, D, E, F, and in agglomerative also having those data items I, B, C, D, E, F. In one case, it is individual data elements according to the similarities, how the grouping of elements in all steps. Here also 5 steps are followed for 6 elements, and in divisive also 6 number of elements are divided into each individual set in 5 number of steps in the algorithm. So basically, the name of this clustering algorithm, because we are discussing about the clusters. So clusters means that is how the different data items according to the distance between each other. So if distance factor is considered, how the grouping will be made. Either group each individual elements and make finally one particular cluster, or the given cluster is one and make individual clusters from that. That is the major purpose of clustering. So hierarchical clustering, where several steps are followed in hierarchy, like on tree architecture. That's why the name has been given like that. So the machine learning or artificial intelligence clustering of data points is very essential to make several groups. How similarity between the elements will be considered how similarities will be found, whether it is distance factor or different types of your similarities by this clustering algorithm, how to make the similar data elements. And it should fall under one specific category, whether it is soft clustering or hard clustering. So whether it is falling under one group, or it is falling under sometimes with multiple groups also, some data elements also falls, which is having two kinds of properties, similarities between cluster 1 with cluster 1 and cluster 2, like that. So today we learned the basic concept of clustering along with hierarchical clustering in details, where the two approaches of hierarchical clustering, that is agglomerative and divisive procedure, we learn. The next lecture, I will explain different types of other clustering algorithms in artificial intelligence. Thank you.